Howdy folks, Mr. Reed here. Welcome to OMQ. So for today we're going to be taking a look at stretches, horizontal and vertical, but we're also going to take a look at reflections. So it's kind of almost a little wrinkle to stretches, and that's why I usually bundle them in together. But we'll see that in just a second. So if stretches and reflections are what you want to do, you're in the right place. Let's get to it. All right, so up above are two questions that are asking us to take a couple of functions and go from the algebraic forms that are present up above and turn them into a word description. So one of the things that might throw us off a little bit, depending on if you're used to seeing it or not, are the negative signs that are involved in the locations of the stretches. So as we saw before, we can generalize stretches to A onto F onto BX. So the A controls the vertical stretch, it's the vertical stretch parameter, and B is the horizontal stretch parameter. But the funny thing is, a little bit awkward, and you pretty much have to memorize it, is that the B value is not the stretch factor. It is 1 over B, that's the stretch factor. So it's really important to make sure you're aware of that so that you don't just copy over the number that you see in the B position. Now, what's going on in our first question, so not generally anymore, but in the g of x that's specifically above me right now, is g of x is equal to 3 onto f of minus x. So what that actually means is that we have an a value of positive 3, but we have a b value of negative 1. The coefficient on the x that's inside the bracket there is a negative, so negative 1 is what value that's actually representing. So that negative is the first time that we've kind of bumped into that if you were following along with the mild video that I did. And that's actually what's going to denote our reflection. And that makes sense because what happens is instead of being passed, in this case the argument, instead of being passed, for instance, an x value of 2, it says, oh, actually look over at negative 2 instead and write down what's there. And at 3, you'd write down instead what's at negative 3. And at negative 3, you'd write down what's at positive 3. The reason why that's important is everything that used to be to the left of the y-axis is now on the right, and everything that was on the right is now on the left. This is what we call a horizontal reflection. The labeling for the reflection is which direction the points move. So it's a horizontal reflection because they move left to right. But what the line of reflection is actually the vertical line that is the y-axis. So sometimes people get a little bit confused because they want to say that the x-axis should be involved in the horizontal reflection, but that's not quite right. If you set up a mirror vertically and you flipped things across that mirror, that would be left to right horizontally. So vertical line, horizontal reflection. So that's what this negative is doing in this position right now. It's going to take all the points that are on one side of that y-axis and flip them over to the other side, and vice versa for the left to right, right to left. All right, so what that means here is that we have a vertical stretch of 3, and we also have a horizontal reflection. All right, so that's all there is to that one, and that's what the negative sign's doing, but we also still have that vertical in the A position, so that A parameter, as we talked about before, is the vertical stretch. So that 3 value that's there actually is our stretch factor. And we don't have to worry about the reciprocal for the horizontal because it's actually a negative 1. And if you express negative 1 as a fraction, for instance, it would be negative 1 over 1 or negative out front. And if you do the reciprocal of that, it's still negative 1. So it actually doesn't matter. That actually would be a stretch factor of 1, and the negative is just what's doing the reflection. I usually will say that the stretch factors are only positive numbers, so that's how I take care of things. And then I will denote separately, as I did here, that we have, for instance, a horizontal reflection. So I use the word reflection to tell people about that. If there had been a stretch as well, I would have said that the horizontal stretch was positive whatever. If it was a -2 in there, I would say stretch is +2, but the function is also experiencing a reflection. All right, so I'm going to go ahead and get the next one, which is n of x is equal to -f onto 1/4 x. All right, so first of all, we also in this case are experiencing a negative sign. It's in the other spot, which is in the a value position. So we're probably expecting that this is going to make it so that there is a vertical reflection. And if you think that, then you're right. So the way that this works is if the y value that it used to kick out was a -10, there's now an extra negative sign in front of it, which means the y value is +10. So that would have taken the point that was down here and it would have flipped it up to be up above the axis instead. If it had been a +3, it would now be a -3. So things are flipping top to bottom now. And again, just to be clear, the line of reflection is actually the horizontal line that is the x-axis. And we are flipping vertically around that line. So points move vertically, so we call it a vertical reflection. But the line of reflection is actually a horizontal line. In this case, y is equal to 0. Now, it is important to know that some people will say these things differently. So I've said horizontal reflection and vertical reflection. It is also entirely okay to call a horizontal reflection a reflection about the x-axis. Sorry, nope, it's not. A reflection about the y-axis, because the y-axis is the line of reflection for your horizontal reflections. And then you could say for your vertical reflections, top to bottom, that it is a reflection about the x-axis. So if you see the terminology reflection about the x-axis and about the y-axis, or you'd like to use those instead, that's totally fine. I tend to stick to the horizontal and vertical reflection, but just to let you know that those exist and are pretty common. So in this particular case, as we were saying, this is going to be a vertical reflection. And to go along with that, there's also a b value of 1/4. And we said that the b value is not the stretch factor, but it's the reciprocal of the stretch factor. So 1/4 flips to be 4/1, more simply written as just a 4. So we have a horizontal stretch of 4. So that actually, a stretch of 4 means it's going to become wider. So whatever the function used to be, and this is just a general function. We don't actually know the shape of it. It's just written algebraically. And I've never defined what f is. So whatever it used to be, it is now going to be basically 4 times stretched out this way. So that's these two examples. So we have our word descriptions for the 2 algebraic examples up above. Hopefully that was helpful. If it was, like, subscribe, and thanks for spending your time with me. Take care, folks.